Coral reefs are underwater ecosystems held together by calcium carbonate structures secreted by corals and can be up to 400 million years old. They are located in tropical oceans near the equator and are estimated to be worth at 180 billion US dollars. They are also the most marine biodiverse ecosystems in the world. Coral reefs on average absorb 97% of the energy of the waves headed for shore, protecting the shoreline and coastal cities that reside there. To build man-made barriers that work as efficiently as the coral reef does would cost around $20,000 per meter, whereas protecting and conserving the same coral costs just over $1,000 per meter. Another reason why we must do everything we can to protect it. In 2000, it was determined that 27% of the world's reefs have been effectively lost, the largest event responsible for this being the massive climate-related coral bleaching event of 1998. This destroyed about 16% of the coral reefs of the world in 9 months. Part of the destruction of coral reefs can be attributed to tourism and human activity. Human activities popular in waters where coral reefs live, like scuba diving and boating, lead to the death and destruction of reefs. Scuba diving often leads to physical damage and also stirs up sediment that can kill the reefs. Anchors from boats often hit the reefs and break them. Also, tourists breaking off pieces of coral to take home as a souvenir of their trip is a huge issue. All of these factors add up together and make a huge impact on the coral reefs.
When it comes to the biology of coral reefs, 3 animals and climate change are most affected. The first animal is the butterfly fish. This is a corallivore that feeds on coral polyps. Due to all the pollution of human beings on the coral reefs, their chance of survival isn't very high. They are important because they assist in keeping algae from smothering corals, causing their food source to disappear. Secondly is the spiny lobsters. They rely on coral reefs for protection during molting. They are predators of sea urchins, which feed on kelp forests and destroy them if populations are not predator controlled. And due to the pollution put on these coral reefs, the spiny lobsters can perish, causing a depletion of kelp forests. Thirdly is the hawksbill sea turtle. The hawksbill sea turtle is becoming critically endangered species and are highly dependent on coral reefs for their food sources. They help with nutrient cycling from ocean to land and maintain healthy seagrass beds and balancing food webs. At the current rate of coral reef degradation, 60% of the world's reefs could be lost within the next 30 years. Lastly, climate change. Corals cannot survive if the water temperature is too high. Also, through global warming, this leads to increased levels of coral bleaching, and it's predicted to increase in frequency and severity in the coming decades.
Coral reefs are primarily built up of aragonite shells, which are a crystallized form of calcium carbonate. These aragonite shells are known to form a symbiotic relationship with one of the smaller types of coral known as zooxanthellae, which live on the aragonite and give the coral reefs their bright colors. One of the main dangers to coral reefs, though, comes in the form of coral bleaching. This is the process in which the zooxanthellae is forced off the coral, and thus losing the color pigmentation and becoming a pale or white color. This can occur in a number of ways of the ocean being polluted. One of the main ways this can be done is from the harmful chemicals being dumped into the ocean in the form of sunscreen or even cyanide, which is used in a type of fishing in order to stun the fishes and catch them. It has been found that these substances can activate viruses that were inactively residing within zooxanthellae and thus causing them to no longer be in a symbiotic relationship with the aragonite. Another direct cause is the ocean acidification, which is the process of the ocean becoming more acidic in pH level over the years. More than 30% of carbon dioxide we emit into the atmosphere ends up dissolving in the ocean. When this occurs, the carbon dioxide can compromise or even prevent the calcium carbonate of coral reefs from growing or producing more of the aragonite. The ocean's pH level has increased by 0.1 on the pH scale since the industrial evolution occurred, which will make it difficult to form new coral reefs. Given all these reasons, it is important that we ensure the safety of the coral reefs for the future of our planet.